Hello everyone, welcome back, and I hope you're doing well. And whatever you are preparing for is also going well in terms of your preparation. So, in the last video, we had talked about your classical normal linear regression model. Okay, I hope you saw the video. Today, we'll be talking about your point interval estimation and your confidence interval. Okay, so previously we have discussed that our estimates can either be point estimates like we had the OLS estimators, or we can have your interval estimators. So we have discussed about the point estimate. So my estimate or my estimator has a single value here, okay, or my beta 1 hat and beta 2 hat will have a single value here. In the case of interval estimator, they will have a range of values, okay, say uh, between 10 to 15, or any range, okay. It can be a very small number or a very big number. So the estimators, they will not have a single value or they will not be like your OLS estimate. Instead, they'll be having a range of values, okay. We'll say that my estimator or my estimated value lies within a range, okay, and through that I'll be making inference about my population parameter. So this is the point of discussion today. So instead of relying on the point estimate alone, we may construct an interval around the point estimator. So suppose beta 2 hat is the point estimator. So instead of just having a single value, I can create a range of values in which my actual parameter can lie. Okay, that is beta. So how do I create this value? So I can say that I can say that if if uh, there is a range of value and this range is being created with the help of your standard deviation or standard errors, okay. So how many standard deviation away is my estimated value of the true parameter from the actual value. So if it is 2 standard deviation or 3 standard deviation, so we can create a distance around the actual value of the population parameter where in which my estimated value can lie, okay. And if in this created range, okay, in this range or in this interval, I'll try to check whether my actual population parameter is being included in this range or not. So my actual population parameter can be a part of this range, and if it is, then we are having an interval estimate of my population parameter, okay. So how, so and then we can assign a probability. How probable is the fact that my actual population parameter will lie in this range that is being created with the help of the standard deviations around the true population parameter. I hope you get the point. When I'll explain a little more shortly, then this point will be clear even more. So the rough idea behind interval estimation is this only, okay. So to check whether how close is beta 2 hat to beta 2, okay, we try to find out two positive numbers, delta and alpha, okay. So this value lies between 0 to 1, such that the probability that the random interval, so the interval is beta 2 hat minus delta, comma, beta 2 hat plus delta. So this is the interval contains the true contains the true beta 2. Okay, so the probability that this interval contains the true beta 2 value is equal to your 1 minus alpha. So I define two positive numbers, delta and alpha, and they are such that alpha lies between 0 and 1, and the probability that my true population parameter lies in this range, this delta can be any number. Okay, this range depends on delta, and this delta can take any positive value. And if my true population parameter lies in this range, then what is the probability of that is being given by my 1 minus alpha. Okay, so let's see what this means more deeply. Okay, so if I have to write this in the form of equation, it means that probability that beta 2 minus delta beta 2 and beta 2 hat plus delta. So my beta 2 hat is lying in this range, and the probability of this is equal to 1 minus alpha. So this is called your confidence interval. Confidence interval, or the range in which beta 2 hat or the true population parameter can lie, and this is called your confidence coefficient. Confidence coefficient. I hope this is clear. And this alpha lies between 0 to 1, and this is called your level of significance. This alpha is called your level of significance. So we'll talk about these terms more deeply. And your beta 2 hat minus delta and beta 2 hat plus delta are your confidence limit. Confidence limit. So this is your lower limit, this is your upper limit, and if your true population parameter or beta 2, sorry, population parameter, true population parameter lies in this range, okay, it means that you are confident enough to say that the probability, or there is 1 minus alpha probability of your beta 2 hat being in this range. Okay, and these are your confidence limits. So your beta 2 value should not cross these limits. Okay, this is what confidence interval or interval estimation talks about. So I hope confidence interval is also clear. I mean, uh, this is your confidence interval. Okay, so let's take an example. Okay, let's take, so example. Okay, so if alpha is equal to 0.05, or in percentage terms it means that it is equal to 5%. Okay, the probability that the random variable or the random interval includes true beta 2 is 0.95 or 95%. This implies the interval estimator gives a range of values within which the true beta 2 may lie. Okay, so 1 minus alpha is actually the probability. So if alpha is taken to be as 0.5 or 5%, the probability becomes 95%. Okay, so sorry. So this is the probability. 1 minus alpha is the probability. So you are defining delta and alpha. Okay, so if you take alpha equal to 0.05, 0.05, it means that you are uh, saying that you are 95% confident, or the probability of beta 2 hat lying in this interval is 95%. So if you can reduce this value, so if you change this value of alpha, your probability of beta 2 hat, sorry, beta 2 or the population parameter lying in the confidence interval or the interval changes. Okay, so if you make it to zero point 0.1, then 1 minus alpha becomes your 90%. Okay, or this probability changes to zero point 0.9 or 90%. Okay, similarly, if you reduce this, this probability increases. Okay, so alpha is in a way being defined depending upon your uh, convenience and how much sure you want to be about your population parameter lying in that interval. Okay, so we'll talk about how we choose alpha and about the level of significance more deeply in the upcoming videos on hypothesis testing. So we'll see how important it is to define alpha and what are the problems that we face while choosing a l- particular value of alpha. So I hope this video was clear, and this the point that I was trying to inculcate here was also clear. So I'll see you in the next video. Till then, take care.